Okay, so it's a pleasure to be here, and especially to talk about one of the great achievements of genetic engineering, namely something that goes by the title of GMOs in Europe and around the world. In fact, it's really a misnomer. I'm sure all of you are aware that almost everything that surrounds you and that you eat every day is actually genetically modified in some way. And the latest advances that go under the rubric of GMO are really just the next advance in the way in which we can improve plants, animals, everything around us. I'm sure many of you have dogs. Every dog has been genetically modified. There's no such thing as a non-genetically modified dog. So I want to tell you how I got started in this, a little bit about the history, and then I want to delve into what are GMOs, what is this technology, what it's all about. And you should realize right from the very start that there is not a single example, not one, of a problem with GMOs. Not a single one. You listen to the opposition, they tell you about Seralini, they tell you about cancer, they tell you about all sorts of things. There is just no truth in any of this. And so what I want to do is to make sure that by the end of my presentation, you too will discover what the real story is and what the science tells us, as opposed to what the anti-GMO activists tell us. So I'm not a plant biologist. When I did my graduate work, I actually worked on a bit of wood that came from Brazil to find out what chemicals were in it. That's the closest I've ever come to being a plant biologist of any sort. Now, I was invited to go and celebrate the 80th birthday of this gentleman, Mark Van Montague, and he was the person, together with Jeff Shell, and at the same time and independently, Mary Dale Chilton, discovered how nature moved DNA from bacteria into plants. And so they had a big celebration for his birthday, and he'd been an old friend of mine for many, many years, and he invited me to go and give a talk and listen. And what I discovered after listening for one day of a symposium all about plants and all about people trying to do good recombinant DNA work in Europe, that they were just being harassed, right, left, and center. Everything was being put in their way to make it difficult for them to work, difficult for them to do the experiments. In fact, this symposium, there was a big demonstration by Greenpeace outside of it. And this was common. This was what happened in Europe. And every single speaker mentioned this difficulty of working in this area because of the untruths that had been spread by the anti-GMO activists. Now, the following day, I had been invited to go and talk to the European Commission about the future of healthcare. Not that I claim to know very much about that, but, I could think of a few things and talk some good words about vaccines and so on. But I decided, after listening to this day, that I was going to change my talk altogether and that I would use a different theme. And the theme that I chose to use was the theme that food is medicine. If you go to bed hungry at night, you're not looking for antibiotics, you're not looking for fancy drugs that we might be looking for in the US or in Europe. What you need is food. Food is your medicine. And so I talked about the GMO issue and mentioned many of the things that I will mention to you. And at the end of that talk, an Italian senator came to me and said, I heard what you had to say. I was totally opposed to GMOs before you spoke, and now I think they're the greatest thing I've ever heard of. And she said, I'm going to vote for them whenever I get the opportunity. And a number of other people who were aides to other senators came and said, we've not heard a lot of this before, because Greenpeace and the anti-GMO people had essentially shut down the scientists, the plant scientists who really know this area, from talking. And they said, one of the reasons that we get hit with all the time is because a lot of the people working on plants get money from big agribusiness. Monsanto supports them, Syngenta supports them, other places support them. And so they just get labeled as being shills of industry. They're just telling the industry line because industry is paying them. And I thought, well, here might be an opportunity where I could, in fact, do something good. I'd run a few previous Nobel campaigns for good causes. And I thought, of all the Nobel Prize winners that I know, there is not a single one, not one of us, who works for the agricultural business. We're not in with big agribusiness. We have nothing to do with it. And so this argument that the anti-GMO people were using could not be used against us. And that seemed to me quite a good thing. And so I started to think about this campaign, figured out how we would do it, went through, talked to a number of my Nobel friends and said, you know, would you support this? Is this something you would be on board with? And pretty much everybody I spoke to said, yes, this is very much something we're for. We don't like the fact that there is all of these lies being told about science and what science can do and how it can help. And so the campaign got properly launched in June 30th in 2016. And at that time, I had a press conference down in Washington. We had a couple of Nobel laureates who called in and made some comments. And we did what we could, and we got a huge amount of press coverage after that. And a letter was sent to Greenpeace, a letter was sent to the head of every UN delegation in New York. And basically what we asked was, why don't you stop scaring the public with all of these stories that are not true when the science says they're perfectly safe? There is no problem with these. Not a single problem has emerged that is credible. Now, of course, you listen to the anti-GMO activists, and they tell you these stories of cancer from this, cancer from that. Not a single one of these stories, even though some of them were published in the scientific literature, in every case, when the studies were repeated or when the work was looked at carefully, it was simply wrong. And Seralini is perhaps the arch enemy as far as GMOs are concerned. And he published a paper, said some rats in the lab got cancer. People looked at the studies and says, but that can't possibly be true. He hadn't done the experiments properly. The science was very poor. And he was forced to retract the paper, and the journal said, we won't publish it. And so what did he do? He goes and publishes it in another journal that has no peer review. No scientist looks and says, this is okay. You listen to the anti-GMO people, they tell you this all the time. This is absolutely terrible stuff that this man has been doing. So that's how we got started. This was the poster that we looked. At the time that we sent it in, we had, I think, 107 Nobel laureates who had signed on. Now we have 142. And basically, on the left of the little cartoon up there, which was drawn by a cartoonist in Iowa, it's basically someone trying to scare you about what GMOs can do. And on the right-hand side is the little boy who sees GMOs as food. And I think you can tell which side of that equation I stand on. We have a website called supportprecisionagriculture.org. There's a lot of information on there about the campaign, about the things that we do, and about GMOs in general. And we have the names of all of the laureates who support this. They're all listed there. And you too can sign on and join us and say, well, you're a believer as well. And I would encourage you to do that and to look at it. Now, one of the things you have to realize is that food means agriculture. And agriculture got started about 10, 12,000 years ago when the hunter-gatherers realized that instead of having to go in the forest every day to find the food they wanted to eat, they could take some of these plants and grow them in their backyard. And in this way, over time, they discovered that some plants grew much better than others. They discovered that sometimes, if you had two different plants growing together, they would cross-pollinate, and you would get some new varieties showing up that were actually better than the ones they'd been growing previously. This was the origins of the genetic modification that takes place in plants. And this has been going on for 10 or 12,000 years using methods that are considered natural. That is, this is the way that nature reproduces. A way to think about it is every time we make a baby, that baby is genetically modified. It's got a few genes from the mother, a few from the father. It doesn't usually look like either one. The same thing happens with plants. When you cross plants, you get a mixture of the genes. If you look at what happened for corn, for instance. So on the right-hand side, you can see what corn looks like in most supermarkets these days in the West. On the left, this is teosinte. This is the original corn that used to grow in the forests of Central America. It doesn't look anything like the corn that grows today. And along the way, people have slowly adapted, and now we have these beautiful corns because we've selected the things that look good, that sell well, they taste good, and this is how we make plants. This is the only thing that really relates directly to science that I'll tell you, and this is just for those people who are not scientists in the audience. Conventional breeding, once we figured out what was going on, we realized that we could do the conventional breeding in the lab, and so we would work on that, and the idea is you've got a nice variety up here that you sell. So this is the one that we're working with and selling, but we want it to grow a little taller, or we would like it to produce a little more grain than it used to. And so what do? We find a wild variety that has the characteristic we want and that is missing in the one that we've been growing at the moment, and we make a cross. And then after you make the cross, the first time around, half of the genes come from the elite variety, those are the white ones that show up here, and half come from the wild variety, those are the yellow genes that show up there. Now, you can pick the ones that have the gene you want, they have the characteristics you want, but they've got a lot of other genes in there too that maybe you don't want. And so what you do now is you keep crossing these hybrids back to the original one, so that you keep adding more and more of the original gene set into the hybrids you've been making, until eventually you get the desired variety, which is picked the that you want. What's happening? Okay. In addition, it's also got a lot of other traits that we don't know what they're there, but they don't seem to affect the way it grows. And so that means you have to realize when you look at anything that has been traditionally bred, you know some of the things that are in it, but there are plenty of things you don't know. And I'll show you the consequences of that comes from traditional breeding. On the right-hand side is the way that Mark van Montague discovered bacteria were able to transfer DNA into plants. He studied something called agrobacterium, and it has a little piece of DNA in it, we call it a plasmid, that is in the bacterium, and this bacterium has figured out how to get it into the plant cell that the agrobacterium likes to grow on. And what Mark realized, well, was that if this plasmid would do it naturally, and would do it with genes that were already on the plasmid, perhaps we could take a gene that we wanted to put in the plant, put it on the plasmid, and use the agrobacterium to put it into the plant. He did that, it worked really well, and this was the basis of what are now called GMOs, okay? Genetically modified plants. This is not something that is unnatural, this is what nature does all the time. And we now know, as we've been sequencing the genomes of some of these plants, we realize they've picked up genes from all sorts of things that we had no idea about before. This is something that goes on in nature all the time. Yet Greenpeace will argue that this is inherently dangerous, where you take one gene, you know what it is, you put it into the plant, this is very dangerous. But you take a load of genes, mix them up, end up, this is okay, this is fine. And why? Because we've been doing it for a long time, and we've never really looked to see whether these plants are all safe or whether they're not. I like to use this analogy because I think a lot of people who are not geneticists, not scientists, like to have some sort of metaphor that shows them, some analogy that shows them what's going on. And so the analogy I use is, I've got a car, it's got a GPS system in it, and I've got another one that has no GPS system in it. How do I move the GPS system from one car to another. If I were a traditional breeder, I would take the two cars apart, mix all the parts together, make two cars that way, and then pick the one that had the GPS system. But I think you all know, as well as I do, the sensible way to do this is to take the GPS system, unplug it, and put it in the car where you want it to go. That is the GMO method. That is the way that modern agricultural scientists, agricultural breeders, this is the way we make the new plants. Greenpeace will tell you that if instead of two cars, if I take the GPS system, not from a car, but from a plane, and put it in the car, all sorts of bad things are going to happen. Maybe the car will fly away. They will tell you the most unbelievable rubbish in order to get you scared. And what they've done is they've learned very well from the people who make movies in Hollywood. Okay? We know how easy it is to scare people. People actually love to go to horror movies and watch these movies that get them scared. But usually, you know it's a movie, and even though you may be scared for a little while, even a little while after the movie ends, you know that it's just fiction. Greenpeace never tell you about the fictional aspect of this. They just want to get you scared. And I think the thing that we have to realize is that what's important is the product, not the method. That is, when I do some genetic modification, whether it's by traditional breeding or by using these GMO techniques, it's the product that is important. Is the product safe or is it not safe? Those tests are not usually done for traditional breeding methods. And the result is something that I'll tell you about in a moment. You have to realize plants have a big problem. Just as you or I, if we're out in the jungle and we see a lion, we can run away. But what do plants do? When a bug comes along and wants to eat that plant, what does it do? Well, it can't run away. And so if it's going to survive an attack from a bug, a human, from anything, it has to protect itself. And what does it do? It uses pesticides. Plants are full of pesticides. If they weren't, they wouldn't exist. They'd all have been eaten. There'd be nothing left. And so some of these pesticides, perfectly safe, we've been eating them for years, there's no problem, but some of them are not quite so safe. Here's an example, celery. I'm sure many of you in this room have eaten celery. You've enjoyed it, it's been nice. But there's a nice story about celery. The ladies who used to pack up celery for sale in the supermarket would take the celery and cut it into pieces so it would fit nicely into the package. And in doing so, they used to get the celery juice on their skin, on the skin of their hands. And many realized that they were getting a surface dermatitis as a result of this. And some of them even got skin cancer as a result of this. And of course, they started wearing gloves immediately. Why did it happen? It happened because of this compound, 5,8-methoxyseralin. This is something that celery uses to stop bugs from eating it, and so that the bugs die. These are many different plants that we use as food that also have this compound in. This is a potent carcinogen, very dangerous carcinogen, but the amounts in the plant are extremely small. It might cause a little damage to one or two cells, but your body is able to repair these because we have very good repair mechanisms. So for us, it really isn't a problem, but if celery was a GMO, you would not be allowed to sell it. You wouldn't be allowed to eat it. It wouldn't be in the supermarkets. And this is where it gets to be ridiculous. This is why the product is important. It doesn't matter that maybe it's got some of these compounds in. If it's still safe to eat, then it's safe to grow and safe to sell. Now, I want to talk about food in developing countries because this is where the Nobel Campaign is really concerned. To be honest, we don't care about the US or Europe or what they want to do. There is no shortage of food. Look around outside, you don't find a lot of skinny Europeans. Skinny Europeans went away a long time ago. And so when you start to think about where food is needed, it tends to be in the developing countries. This is where you find young children who don't get enough to eat and don't get good nutrition. And you might think, well, we can improve these crops using these new precision methods, using the GMO techniques, where it's really needed in the developing countries. Europe doesn't need them, so why would Europe be against these particular methods that can help the developing world, but they don't need them in Europe? And so why don't they do it? You think it could be politics? Could it be money? Well, in fact, it's both. What happened was that the Europeans didn't want big agribusiness to control their food. They wanted to control their own food, and they saw Monsanto, when Monsanto first introduced GM foods into Europe, they thought that Monsanto was trying to take over their food supply. And you know, the Europeans are as interested in food security as the rest of us. But Greenpeace had an awakening. They realized here was the way to be against GM foods. Now, originally, maybe they had some good ideas. Originally, their original position was, well, GM foods may be dangerous. They usually, if you listen to them, will use may. And so what we need to do is to test them and make sure that they're okay. Well, all of those tests have been done, but Greenpeace is still not satisfied with that. Why? Because this has been the best fundraising campaign that Greenpeace have ever had. You know the annual budget of Greenpeace? I'm sure you don't. I don't. But the people who estimate these things, you know, Greenpeace don't make it publicly available. People who estimate it to be about 500 million euros a year. This is a not-for-profit organization. And where did all of this money start pouring in from? It started pouring in as soon as they started their campaign. Now, of course, you could have said, well, we don't like Monsanto, so we'll just ban Monsanto, but that won't work. Why won't it work? Because the farmers buy their seeds from Monsanto, and they can't afford not to. And so you tell everybody, this precision breeding method, these GMOs, they're dangerous, okay? And with the oldest political trick in the game, they say, we will protect you. Vote for us. We will protect you from these dangers. And in this way, Greenpeace and the Green parties in general not only made a lot of money on fundraising schemes, they also got political power. And that is still evident today. If you look around in Europe, the Green parties have a great deal of power. And this all came because of their anti-GMO campaign. So you can see why Greenpeace are not so keen to say, well, actually, GMOs are okay. Even though they claim to be scientists, they must know the science. They simply lie about it, and they won't discuss it. I've been trying to meet with the leaders of Greenpeace to talk with them about this, because I have the perfect excuse that they can use for coming out in favor of GM foods. And that is that they can say, well, we were right all along. We asked for experiments to be done. The experiments have been done. They're clearly shown to be safe. Now we're pro-GMO foods, and now we will get on and do all the good stuff that we've been doing in other spheres. They won't do that. They won't even talk to me. And of course, what happens in Europe quickly soon spreads. And so they couldn't make the argument, well, these things are dangerous in Europe. You know, Europeans really can't take these things. But for the developing countries, they're okay. And so what do? They go to the developing countries. And they convince your governments that these things are dangerous. And we now see there are many, many countries that have banned GMOs completely because of this fear that has been spread by the anti-GMO movement. I'll just quickly go through one or two cases to show you the effects. Vitamin A deficiency is a major problem in many poor countries. There's simply not enough beta-carotene in the diet of a lot of people to produce the vitamin A that is necessary when babies are starting to develop. And if they don't get enough vitamin A, they go blind, they have defects in their muscles, defects in their immune system. Two men Ingo Petrikis and Peter Bayer, decided they were going to do something about this. And they thought, rice is a major crop for many of these people. What if we could put the genes that will produce beta-carotene into rice so that people would get enough vitamin A, because beta-carotene is the precursor of vitamin A, they could get enough in their diet that the children would no longer go blind. So they did this. 1999 was when they first had this available in the lab. And typically, from that time, it just takes a few years before the crops have been made ready for the field and ready to go out. 1999, 20 years ago. But it's a GMO. And now, this year, finally, we're going to see this. And thanks to Bangladesh, of all places, Bangladesh had a government that realized that this was something that was worth pursuing. This is where the science fiction comes in for the anti-GMO campaign. Golden rice, they realized that golden rice was actually a pharmaceutical. It wasn't just food, it was a pharmaceutical. And one of the great benefits that has come from GMO technology are things like human insulin. You know, if you're diabetic, you take human insulin. Where does that come from? Well, it doesn't come from humans. Okay? Where it comes from bacteria or yeast that have been engineered to produce the human version of insulin. This is a GMO. Have you ever heard Greenpeace say anything negative about that? I've never heard anything negative from them about that, but it's a GMO. And I think they saw that this was going to be exactly the same sort of situation. And since 2002, maybe 15 million children have died because of vitamin A deficiency. I want to know how many kids have to die before we think that a crime is being perpetuated against humanity here. In my view, this is something that is terrible. You know, if this was a genocide in Rwanda, we'd hear nothing but stories about the perpetrators. We hear nothing about the perpetrators here. Now, okay, I'll go quickly through one or two diseases that affect countries in Africa that can be solved very easily. First of those is Xanthomonas wilt. This is a bacterial disease. It's killing bananas. There is no natural solution, so one cannot use traditional methods in order to solve it. There is no version of banana that is resistant naturally to this. But sweet peppers has two genes in them. You move these genes into banana, and now banana is resistant to Xanthomonas wilt. There's another one, the fall armyworm. Fall armyworm, a tremendous amount of maize is being killed by this worm, which loves to eat it. There's a beautiful solution. This was discovered in the southern part of the US many, many, many years ago. And so all of the maize that is now grown in the south of the US has what is called a Bt gene. It's a bacterial toxin that will kill the fall armyworm. If the fall armyworm eats it, they die. This has been adopted in South Africa. This is all of the maize that's grown in South Africa, is all Bt maize. But Zimbabwe, Robert Mugabe, in his wisdom, decided that this was too dangerous to be grown in Zimbabwe, not allowed to grow it. Zambia, Namibia, Malawi, and this worm spreads like mad. It's a very highly communicable disease. Let's go back to Bangladesh again. Bangladesh were having problems with eggplants. This is a staple food in Bangladesh. They couldn't get enough because of pests. Bt eggplants were made, and now Bangladesh, they produce so much eggplant, they can't eat it all. They have to export it. And interestingly, farmers in the neighboring provinces in Assam, in India, where they were having the same problem, but India has a ban on GMOs, the farmers go over to Bangladesh and get the seeds and grow it themselves and just don't tell the government. Hawaiian papaya, this was almost wiped out by virus, ring spot virus. Scientists, some 20 years ago, made a Hawaiian papaya that was resistant to ring spot virus. And now if you go anywhere in the US and pick up a papaya, it almost certainly is a GM papaya. It's not labeled as such, though. Why? Because the government decided it was going to be too dangerous when the farmers protested, and it would wipe out the papaya industry. And so what did the government do? They decided, well, we will grandfather papayas. It was done so long ago, we'll pretend it's natural. And it's only new stuff that has to be labeled. So the bottom line here is if you don't want to eat foods derived by GM methods, then don't. This is your choice. No one makes you eat anything. But if anything, they're probably safer than traditional foods. Don't say you're not eating them because they're dangerous. For developed countries, food really isn't a problem, except for those that don't distribute it fairly to the poor people. But for the developing countries, it is a major problem. And it's not just the quantity of food, it's the nutritional value of food. And all of this can be improved using GM methods. The bottom line is we need a lot more science in politics, and ideally a lot less politics in science. Politicians should listen to the scientists they fund. Why fund them? You know, if you're not going to listen to the results of their experiments, why do you fund them? And stop supporting this idea that foods must be inherently dangerous when they're produced using precision methods. Science shows that they're not. Not one single piece of evidence. Look in Europe. In Europe, you're not allowed to grow GM foods, and yet they import millions of tons of the products of GM food to feed their animals. Cattle, pigs, whatever, millions of tons of GM soybeans go into Europe. The Europeans apparently don't worry about their animals. These things are perfectly safe for their animals. It's just for humans that it's bad. Well, I beg to differ. Soybeans taste good whether they're traditional or GM. And what we need to do is to get some action among civic leaders. The major religious leaders should speak out. We're trying to get the Pope to make a statement on this because that is something that could have a big effect. But there are many other groups that are basically in favor of GMs. They should speak out. Ideally, one of the countries that someone in this room represents would decide that, well, GM foods are okay. And we're not going to make these tremendously difficult rules that have to be followed. You know, the cost of producing a GM crop by comparison with a regular one is so great that only the big agribusinesses can afford it. And this was what Greenpeace were trying to stop, the big agribusinesses. But now it is so easy to make these things. You can make them, your scientists can make them in your country, make them available. Local companies can grow up to support these, to sell them to people. Tell the Europeans to go to hell. That's my message. Here's an interesting thing. This is the best thing I've heard so far from the Catholic Church. The Vatican tells adherents, tells Catholics how they should behave, what's okay and what's not. Now, one of their great sacraments, Mass, they drink wine and eat bread. The congregation that sets these rules decided that Eucharistic matter, if it was made from genetically modified organisms, it was okay. But if it's gluten-free, apparently it doesn't work. It's the best thing that's so far come out from the Catholic Church about this. Now, there are a bunch of people who've changed their minds. Patrick Moore, this fellow up here, he was the president of Greenpeace when they started this anti-GMO campaign. He's now flipped completely, and he is totally pro-GMO. Stephen Tinsdale, who used to be head of Greenpeace in the UK, unfortunately is dead now, but he too switched his mind completely. Mark Linus is the guy who used to burn the crops in England. He was in charge of this. He's now totally pro-GMO, and there are many others. But the one I like best is this gentleman from Ghana. He used to be head of the Peasants Farming Association. He was totally anti-GMO. He led demonstrations. He went around all over convincing people that GMOs were dangerous. He took a little time, looked into the science, got himself educated, and now he is pro-GMO, and he's going around telling the farmers they really need this. And of course, what happens is when someone from the country takes on this issue, both the farmers, the population, and the politicians are much more likely to listen than myself. I come in from outside, well, I must have some vested interest in it. But the locals, these are the people who can make a difference. And that's why all of you in this room have the opportunity within your countries to make a difference. And if you can do that, you should. And finally, my last slide, I say have a heart. Okay? Non-GMO is a Western indulgence of the rich, but it simply doesn't work for poor people. Take a look at the website, sign on, and ask what you can do for your country. Thank you.